Hey everybody, this is a particular research paper that caught my eye for a few reasons, and so I wanted to make a video on it. The paper is titled, "A Method to Improve the Performance of Reinforcement Learning Based on the Y Operator for a Class of Stochastic Differential Equations Based Child-Mother Systems." The title is not fun to say or to read, but the paper is interesting in and of itself, especially if you're into mathematics. If you're not into the math theory behind AI, this is probably not the paper or the video for you, but this paper is very interesting on multiple levels and multiple fronts for those reasons, for me specifically. So the paper deals very specifically with gradient algorithms, and what it tries to do, it creates a new gradient method that for reinforcement learning. And so within reinforcement learning and within AI overall, there's a general problem, which is the problem of generalizing for AI models. They're not good at generalizing, period, especially like if they're faced with a new situation or is like something where they a new environment where they know absolutely nothing about it. That's where the models tend to like just completely fall apart, right? And then so this particular breakthrough is like their method is around that very specifically, around when you're dealing with reinforcement learning, which is like environment training and simulation training of a model, and then you want to essentially allow the in this particular instance it's utilizing the like where you have the critic method, and then you want to allow the critic to be able to essentially like cut through the noise and make a determination on the environment with all of the noise and inconclusiveness that you'd find in a typical environment situation, and be able to make and draw conclusions off of that. So that's to me a significant breakthrough overall, because this is like a big question, that the big question that we still have around AI, right, is like that generalizability, like, and especially when it comes to reinforcement learning, because reinforcement learning is when this comes out the most. Like, is the model actually understanding its environment and making calculations off of its environment, and like understanding the game, right? And then this first came out with AlphaGo, where AlphaGo essentially lost like very badly to a human amateur, simply because it had never seen the strategy before. Like, the strategy that the human amateur used was like so amateurish it wasn't in any like books or training on the game itself of Go, because no one would actually use it, because like an 8-year-old would be able to beat it, so no one wrote about it. But it beat AlphaGo for that reason. And then so the logic and the thinking is like why this paper would be so groundbreaking on that front would be that this paper solves that problem, right? It gives the model, and this is like the research that people have been going towards on this instance in these scenarios, is giving the model instances where it can utilize and build upon its environment in those types of situations, and highlighting up front like the theory and the math in this paper. So this is a 14-page paper, and it's like 8 pages of math. The mathematical theory behind getting the model to do this is like pretty intense. And so like this is like what caught my eye initially about this paper, and as I'm going through it, because I typically don't see papers that are so rigorously mathematically supported. Like, I can guarantee you that this method works. Like again, 14-page paper, and 7 pages of it are the mathematical equations and backing of the mathematical equations, and the theory behind the mathematical equations that make all of this work. And so I guess to me, like, kind of like the last thing to highlight in this as we go over this is as well, like, so like when people bring up to me like the math arguments, like, well, like, oh, the models are only following like mathematical equations and only utilizing the math that they have built within themselves. My argument to that, and honestly, like, and the question that I honestly ask around that is, like how can we know that humans don't utilize basically like the same exact thing? Like, so this is essentially one framework, right? And then just one particular framework and one particular argument to get the model to think about its environment in a generalized way, and to give it tools to say, hey, here's how you can think if you've never experienced a situation before. And it's a 7-page mathematical equation. Like, just like the math and the support for the theorem is 7 pages. So, like, sure, yeah, like it's just math, right? But that you're throwing into the model, but it's far from just math at that point. Like, it's not. It's a blueprint. It's code in a lot of ways, and then so to me personally, I see a lot of similarities within that and along those things, and then so I find the math behind all of this extremely intriguing for those reasons. And then I think that anyone that says that all of this is just math is way oversimplifying exactly what the math is that we're looking at within this, what this math is doing, and the complexity of the math itself. So, like, I think that overall, those types of statements and theories don't do the math itself justice and don't do these models justice overall when we're talking about it from that level. So if you like this type of content, please like and subscribe. I'll leave the link to this paper in the description of this video as well. Please feel free to read through it. The authors did an amazing job again with their mathematical analysis, and I guess I'll end on this note, and then so like the other reason why this caught my attention as well is because of the like this particular paper is it's coming out of China, like and very specifically, and they're the ones that are very into reinforcement learning on this level, and then so like these papers always catch my eye when they talk about reinforcement learning, because no matter what, this paper is like screened through multiple parties. So this is printed in a journal in China, but even like just how the Chinese system works, they have to go through rigorous tests and like standards as far as like what their papers can actually like say when they come out publicly. So when China makes like big claims around things like these, I think people should pay more attention to it. And then China has been releasing a lot of research recently around reinforcement learning and unsupervised learning, and I think that there's reasons behind it. I personally plan on putting out a lot more videos around reinforcement learning and unsupervised learning, because to me this is the major area of research and focus for the near-term future. So thank you very much.